Hello, my name is Daniel, and today we will be going over the 2004 AMC 10A. So let's get started. First problem, you and 5 friends need to raise $1,500 in donations for a charity. Dividing the fundraising equally, how many dollars will each of you need to raise? It says you and 5 friends, so that means it's 6 people. 1,500 divided by 3 equals 500 divided by 2 equals 250. The answer is A. Second problem, for any three real numbers a, b, and c with b is not c, the operation x is defined by x, a, b, c equals a over b minus c. So this whole thing would be x, so there's an x, and then 1 over 2 minus 3, 2 over 3 minus 1, 3 over 1 minus 2. So this would be x of minus 1, 2, and minus 3. Actually, this isn't 2. This would be 1. So this would be minus 1 over 1 minus 3, which is minus 1 over 4. So it's B. Number 3, Alicia earns $20 per hour, of which 1.45% is deducted to pay local taxes. How many cents per hour of Alicia's wages are used to pay local taxes? So she earns $20 per hour, so $20, this is equal to 2,000 cents, of which 1.45%, right? So it's 2,000 times 1.45 over 100. This is 2,000 times 145 over 10,000. This is 145 over 5. This is 29. So the answer is E. Number 4, what is the value of x? If the absolute value of x minus 1 equals the absolute value of x minus 2, then this would mean that absolute value is 1 has to be plus and 1 has to be minus. So let's say that x minus 1 is plus and x minus 2 is minus, so that would mean that x minus 1 equals minus x minus 2, 2x equals 3, x equals 3 over 2. The answer is D. Number 5, a set of 3 points is randomly chosen from the grid shown. So since 3 points is randomly chosen, this would be 9 choose 3, and the numerator would be the probability that the points lie on the same straight line, right? So it's 1, 2, 3, 4, 5, 6, 7, 8 possibilities. This is 8 over 9 choose 3. This is 8 over 9 times 8 times 7 over 6. So this is 8, 8 cancel, and it's 6 over 9 times 7. This is divided by 3, so it's 2 divided by 3, so it's 3. 2 over 3 times 7, that is 21. 2 over 21, so the answer is C. Number 6, Bertha has $6 and no cents. Some of her daughters have $6 and the rest have none. Bertha has a total of $30 in granddaughters, no great granddaughters. How many of Bertha's daughters and granddaughters have no daughters? Okay, so she has 6 daughters, but in total she has $30 and granddaughters. That means Bertha has 24 granddaughters. And so she has like these packets kind of. So she has groups of 6 daughters, 6 granddaughters. So this would mean that four of her daughters have daughters, right? And so this also means that 2 of her daughters do not. So how many of Bertha's daughters and granddaughters have no daughters? It did say that it did say that she had no great granddaughters. So all of her 24 granddaughters don't have daughters yet. So there's the 24, and then we have the 2 that don't have any daughters. 24 plus 2 equals 26. The answer is E. Number 7, a grocer stacks oranges in a pyramid-like stack whose rectangular base is 5 oranges by 8 oranges. Each orange above the first level rests in a pocket formed by 4 oranges below. The stack is completed by a single row of oranges. Okay, so the first row is 5 by 8, and the next row will be, so it's a pocket formed by 4 oranges below, right? So there's 1 less orange in each row and column. So it's 4 times 7, and then 3 times 6, 2 times 5, 1 times 4. This will be 40, this will be 28, this will be 18, this will be 10, and this will be 4. So this would be 40 plus 28 is 68, this will be 28, and this will be 4, so this will be 32, this will be 100. The answer is C. Number 8, a game is played with tokens according to the following rule. In each round, the player with the most tokens give 1 token to each of the other players and also places 1 token in the discard pile. The game ends when some player runs out of tokens. Players A, B, and C start with 15, 14, and 13 tokens respectively. How many rounds will there be in the game? So, A, B, C, they start with 15, 14, and 13, right? And so the first round will be, A will be giving, so this becomes A has 12 now, B has 15, C has 14, and so next round would be 13, 12, and 15, 14, 13, 12, and then the next round would be this is the biggest number again, right? So it would be 13, no, it would be 11, and then 14, 13, and so if you like split it right about here, then we can see that this group and this group, each of the numbers have decreased by 1, right? So like 12 minus 1 is 11, 15 minus 1 is 14, 14 minus 1 is 13, and so this kind of so this kind of like pattern will be rotating every 3 rounds, and then so the game will stop if it becomes 0 and then 2 and 3, right? So the only way that it will stop is if it reaches 0 and 3 and 2, and so until above this would be 1 to 12 times 3 would be 12 times 3, right? Equals 36. But then we have this one more, so 36 plus 1, because we have this one more round, equals 37. So the answer is 37, it's B. Number 9, in the figure, EAB and ABC are right triangles. AB equals 4, BC equals 6, and AE equals 8, and AC and BE intersect at D. What is the difference between the areas of ADE and BDC? Okay, so if you see here, AD is this triangle, right? And BDC is this triangle. So this minus this is the same thing as ABE minus ACB, right? Because it's just adding ADB to both sides. So ADE minus BDC would be the same as ABE minus ABC. So it would be 16 minus 12. The answer is 4, so it's B. And number 10, coin A is flipped 3 times and coin B is flipped 4 times. What is the probability that the number of heads obtained from flipping the 2 fair coins is the same? So A is flipped 3 times, B is flipped 4 times. What's the probability that the number of heads obtained from flipping the 2 fair coins is the same? So there could be no heads, right? No heads, so this would mean that coin A is 1 over 8, and then coin B is 1 over 16, and 1 head would mean there is a 3 over 8 chance, and then there's a 4 over 16 chance, right? And then two heads, this would be a 3 over 8 chance also, multiplied by a 6 over 16 chance, and then 3 heads would be 1 over 8 multiplied by 4 over 16 chance. So if we add all these together, then we get 8 times 16 is the denominator, and it's 1, plus this is 12, plus this is 18, plus this is 4, right? So this is plus 4. This will be 8 times 16 is 128, right? 128, and then 1 plus 12 plus 13 plus 4, this is 35. This is 35 over 128. The answer is D. Problem 11. A company sells peanut butter in cylindrical jars. Marketing research suggests that using wider jars will increase sales. If the diameter of the jars is increased by 25% without altering the volume, by what percent must the height be decreased? So the diameter increased by 25%. Diameter increased 25%. This also means that the radius will be increased by 25%, right? So if the radius is 4, then this would make the radius equal 5 since it went up by 25%, right? So the previous height was, let's say it was 100, right? And so if the radius was 4, then it will be 16 pi, since this is the base, multiplied by 100. But then this would be 25 pi multiplied by some kind of the new height, right? And without altering the volume. So these two must be the same. So if pi are erased, so 16 multiplied by 100 equals 25 times something. This and this cancel to make 4. So this is 16 times 4. This is 64. And so this and so the new height is 64 over 100 of the new one. So this would mean that it was 36 over 100 decreased. So this is 36%. The answer is C. Number 12. Henry's Hamburger Heaven offers its hamburgers with the following condiments: ketchup, mustard, mayonnaise, tomato, lettuce, pickles, cheese, and onions. A customer can choose 1, 2, or 3 meat patties and any collection of condiments. How many different kinds of hamburgers can be ordered? So Henry's Hamburger. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8. 8 condiments. And then 1, 2, or 3 meat patties. And so how many different kinds of hamburgers can be ordered? So the 3 patties, so we have a 3, and then we have 8 condiments. And we can pick each one to put it in or not put it in, to put it in or not put it in. So there are 2 choices for every condiment, right? So 2 to the 8th power, this equals 3 times 256, equaling 768. The answer is C. Number 13. At a party, each man danced with exactly 3 women, and each woman danced with exactly 2 men. Each man danced with exactly 3 women. Okay, 12 men attended the party, right? 12 men, and then each danced with 3 women. That must mean that there were 36 total pairs. So this is the and so this 36 came up by 12 times 3, right? So this is 36, but this is also equal to each woman dancing with exactly 2 men, multiply the number of women that attended. So if there are n women that attended, n, then 36 would become n multiplied by 2. So n will be 36 over 2 equals 18. So the answer is D. Number 14. The average value of all the pennies, nickels, dimes, and quarters in Paula's purse is 20 cents. If she had one more quarter, the average would be 21 cents. How many dimes does she have in her purse? Okay, so the average value of the pennies, nickels, and dimes, and quarters. So their pennies is 1 cent, nickels is 5 cents, dimes is 10 cents, and quarters is 25 cents. The average is 20 cents. If she had one more quarter, the average would be 21 cents. Okay, so let's say she has n coins in her purse. That means she has 20 n, and then one more quarter means plus 25 cents. This will be equal to 21 cents average multiplied by there's n plus 1 coins, right? So n plus 1. So 25 equals 21 n minus 20 n, right? So this is n plus 21. So n equals 4. So she has 4 coins. So total now would be 20 cents. So 80 cents. And so this would be 50 cents plus 30 cents, right? So 25, 25, 25, and 5 cents. So this would make so she has 3 quarters and 1 nickel. And how many dimes does she have in her purse? She has no dimes, so the answer is A. 15. Given that x is greater or equal to -4 and less than or equal to -2, and y is greater than or equal to 2 and less than or equal to 4, what is the largest possible value of x plus y over x? So this is 1 plus y over x, and it's x is greater or equal to -4 and is less than or equal to -2. So what's the largest possible value? Okay, so since x is a negative number, then we have to make this as small as possible. So 1 plus, and then this would be -4, and then this would be the smallest number, right? So this is 2. This is 1 minus 1 over 2. So this is 1 over 2. The answer is D. Okay, so number 16, the 5x5 grid contain a collection of squares with sizes from 1 by 1 to 5 by 5. How many of these squares contain the black center square? Okay, so the squares that are 1 by 1, there are only one square, so it's this one. And so there's only one. And 2 by 2 squares, they could be 1, 2, 3, 4, 4 possibilities. 4, and then 3 by 3, there could be this one, 2, 3, 4, 5, 6, 7, 8, 9, all of which contain this black center square. This would be 9. And then 4 by 4, there will be 1, 2, 6, and 1, 2, 3, and 4. So that will be 4. And then the last one, 5 by 5, that will be just this whole thing. This is just 1. And so how many of these squares? It's 1 plus 4 plus 9 plus 4 plus 1 equals 19. The answer is D. Number 17. Brenda and Sally run in opposite directions on a circular track, starting at diametrically opposite points. They first meet after Brenda has run 100 meters. They next meet after Sally has run 150 meters past their first meeting point. Each girl runs at a constant speed. What is the length of the track in meters? Okay, so let's draw this. This is the circular track, and they start at diametrically opposite points. So let's say this is Brenda and this is Sally. They first meet after Brenda has run for 100 meters. Okay, so Brenda's run 100 meters and Sally's run X meters. But then they next meet, right? And so from here they next meet after Sally has run 150 meters past. So Sally would be like this, Sally, and then Brenda would be like this. And so this would be, Sally would run 150 meters, and let's say this is y. So 100 to x equals y to 150, right? And so y equals 150, 100 over x. So what's the length of the track in meters? This would be that, let's say 100 plus x times 2, right? Because 100 plus x is only half of the circumference of the circle. So to get the whole circumference, you have to do multiply by 2. And so this will be equal to 150 plus y, which is 150 plus 15,000 over x. So 2 times 1,000. Yeah, 2 times 1,000. 2 times 100 plus x. This will be, this multiplied by x would be 150x plus 1,500,000. No, yeah. So 150,000. So 2x squared plus 50x minus 150, 100. Yeah, we don't need this extra 0. This would be 0, and so 1, 2, and then this would become a 200, 150, and this would be minus. And so here, no, that's not the minus. Here's the minus. And so this is 400 minus 150. And so this would be, yeah. So it's this one, right? So it's 2 minus 150. So x equals 150 over 2 times, yeah. So this is x equals 150 over 2, which is 75. And so what is the length of the track in meters? This is 2 times 100 plus x. So this is 2 times 100 plus 75. So this is 2 times 175. This is 350. So the answer is C. Number 18, a sequence of 3 real numbers forms an arithmetic progression with the first term of 9. If 2 is added to the second term and 20 is added to the third term, the 3 resulting numbers form a geometric progression. Okay, so there's a first term of 9, and then there's a 9 plus d, 9 plus a, and then 9 plus 2a. These form a geometric progression. If 2 is added to the second term, so this is 9 and then 12 plus a, no, it's 11 plus a. 20 is added to the third term, so 29 plus 2a. So the 3 resulting numbers form a geometric progression, and so 11 plus a over 9 squared equals 29 plus 2a over 9. So this is 9 times 11 plus a squared equals no, there's no 9 here. The 9 should have been, yeah, there. 9 times 29 plus 2a. So a squared plus 22a plus 121 equals 18a plus 30. Yeah, plus 9 times 29, so it's 29 by 9, 81. 18, 300 and, no, 261. And so a squared plus 3, a squared plus 30, 40a, 40, no, this is 22 minus 18, right? So this is a squared plus 4a plus, no, a squared plus 4a minus 140. This equals 0, so let's say that this is 14, this is 10, and so this would have to be minus. So a equals 10, and what is the smallest possible value for the third term of the geometric progression? So the third term is 29 plus 2a, 29 plus 2a. No, actually, a could be plus 10 or minus 14, right? And if a is minus 14, then 29 plus 2a, this is 29 multiplied by, and 29 plus 2 times minus 14, right? This is 29 plus minus 28. So this is 29 minus 28, which is equal to 1. So the answer is A. Number 19, a white cylindrical silo has a diameter of 30 feet and a height of 80 feet. A red stripe with a horizontal width of 3 feet is painted on the silo as shown, making 2 complete revolutions around it. What is the area of the stripe in square feet? Okay, so if we stretch this out, then this will be like this, and yeah, and since it's wrapped 2 complete times, this would be a twice of the circumference. So this is 60 pi, and this will be 80, and horizontal width of 3 feet, right? So it's like this, like that, and like right here, this width would be, it says horizontal width, so this would be 3 centimeters. No, this would be 3 feet. 3 feet. And so, what is the area of the stripe in square feet? Okay, so if we push this bar to be like this, then the area would still be the same, right? So if we try to get the area of this one, that's much more easier, right? Because you have only the width, which is 3 pi, no, which is 3 feet, and this whole thing is 80 feet, right? So the area is 240, so the answer is C. Number 20, E and F are located on square ABCD, so that BEF is equilateral. What is the ratio of the area of DEF to that of ABE? And so E and F are located on square ABCD. BEF is equilateral, so this is 60, this is 60, this is 60. And so if the whole thing is 90 degrees, then these should add up to 30 degrees, right? So this would be 15, and this would be 15. What is the ratio of the area of DEF to that of ABE? And so DEF, this is 40 degrees, and no, 45 degrees. 45 degrees, and then this would be 75. And so the ratio of the area of DEF to that of ABE is, let's say that DE, yeah, let's say that this is X, right? Then this would be X, and if this is A, this would be X minus A, and this would be X minus A times root 2. So we would have to draw the lines like that. Then that would present us of a smaller problem, right? Because then this wouldn't have to be X, this wouldn't have to be X minus A. If this was A, then this would be 2A, right? This would be 2A, and this would be root 3A, and so this would be 2 plus root 3A. Yeah, let's take this out. 2 plus root 3A, and so this would be 1 plus root 3A, right? So the ratio of the area of DEF to that of ABE is 1 plus root 3A, and this squared times 1/2 over ABE, right? So this is A times 2 plus root 3A times 1/2, right? So these two are crossed out, and then A squared is also crossed out like that, and so this is 1 plus 3, so it's 4 plus 2 root 3 over 2 plus root 3. This is 2 times 2 plus root 3 over 2 plus root 3, so these two cancel. This would be 2. The answer is D. Okay, so problem number 21. Two distinct lines pass through the center of three concentric circles of radii 3, 2, and 1. The area of the shaded region in the diagram is 8 over 13 of the area of the unshaded region. What is the radius measure of the acute angle formed by the two lines? And it says pi radians is 180 degrees. Okay, so we know that this is pi, right? And so let's say that this angle is x. And so this much out of the whole thing would be x over pi, right? And so using that information, we will be like solving for the shaded area, and it says that the radii is 3, 2, and 1, so that means that this much is 1, this much is 1, this much is 1, right? So this would just be 1, 1, 1. And so let's get the shaded regions. So in the innermost circle, it will be pi multiplied by x over pi, and then this plus 3 pi multiplied by pi minus x over pi, plus this will be 5x, this will be 5 pi, this will be 5 pi multiplied by x over pi, and so this would be x plus 3 multiplied by pi minus x plus 5x. This will be 6x, so this is 3x plus 3 pi, and then the whole thing is 9 pi, right? And so it's 8 over 13 of the area of the unshaded region, right? So of the whole thing, this would be 8 over 13 plus 8, right? So this would be the same thing as 8 over 21. And so since it's 3x plus 3 pi over 9 pi, 3x plus 3 pi over 9 pi would be 8 over 21. And so this would be, if we like take out the 3's, this would be x plus pi over 3 pi. And so let's say cross multiply, and 24 pi equals 21x plus 21 pi. So 3 pi equals 21x, and x equals pi over 7. And so the radian measure of the acute angle formed by the two lines. So it's pi over 7. The answer is B. Problem number 22. ABCDS side length 2. A semicircle with diameter AB is constructed inside the square, and the tangent to the semicircle from C intersects the AD at E, right? So there's this line, and then there's this line. So if we connect them, then this would be like right angles. And if we connect this to here, these two will be the same, these two will also be the same, and So, and if we connect these two, that would also be very helpful. So what is the length of CE, right? And so this has side length 2. Um, yeah, and so this is 1, right? So this has length 2, this has length 1, and then this has length x, let's say. This has length 2, right? And so this is 2 to 1 to root 5. And so that means that it's like this. So yeah, so this triangle is similar to this triangle, and it's also similar to this triangle, right? And so we can like find out, and so we can find out the value of x pretty quickly, since this would be 1, right? So 1 to 2, which is this to this, equals x to 1, x to 1. So x equals 1 over 2, and so CE, this is, so since this is the same as this much is 2, this is the same as this, so this is x. CE is 2 plus x, 2 plus 1 over 2, this is 5 over 2, so the answer is D. Problem number 23, circles ABC are externally tangent to each other and internally tangent to circle D. Circles B and C are congruent. Circle A has radius 1 and passes through the center of D, so this would be the center of D. What is the radius of circle B? Okay, so let's say here's the center, here's the center, here's the center, and circle A has radius 1, so this much would be, this is 1 and this is 1, so the whole thing will be 2, and so D has the radius of 2, and let's say like that. If we connect that, and if we connect this right here, and let's connect these two, yes, and then if the circles B and C have radius of x, radius of x, then this would be x, this would be x, and this would be x, this would also be x, and this will be 2 minus x, right, since the radius of D is 2. What is the radius of circle B? So internally tangent to circle D, yeah. If we put in, yeah, and so if we put in this line, we could say that this line is equal to root 2 minus x squared minus x squared equals root 4 minus 4x, and so this is 2 and the root 1 minus x, right? What is the radius of circle B? So let's say, and so we know this, right? So if we want to get this, yeah, so this length right here must also be 2 plus x, right? Since, no, this is 1 plus x, right? Since this much is 1 and this much is x, so this is the sum of the radii. And so using this right triangle and the Pythagorean theorem, 1 plus x squared would equal x squared plus 1 plus this much, right? 2 root 1 minus x squared. And so 2x plus 1 would equal 1 plus 4 minus 4x plus 4 root 1 minus x. And so 1 erases, and x equals 2 minus 2x plus 2 root 1 minus x. 3x minus 2 equals 2 root 1 minus x. And so what is the radius of circle B? Let's put square on these two, so that would make 9x minus 12x plus 4 equals 4 times 1 minus x. And so 9x squared, yeah, this should be squared, 9x squared plus, no, minus 8x, and then these 4 cancel, equals 0, so 8 equals 8 over 9. The answer is D. Problem number 24, let f be a function with the following properties. f1 equals 1 and f2n is n times fn for any positive integer n. What is the value of f to the 2 to the 100th power? Okay, so let's say that, yeah, so let's see, f1 is 1 and f2 is when n is 1, right? So it's 1 times f1, so it's 1. f4, so let's say f2 squared, this is f2 squared is n is 2, right? So it's 2 times f2, so it's 2 f2 f2 cubed is, this is 4, and this is f to the f2 squared, so this will be 2, so this will be 4 times 2 squared, 2 to the third power, f times 2 to the fourth power, this is 2 to the third power, multiplied by fn, this is 2 to the third power, this is 2 to the sixth power, and f2 to the fifth power, this would be 2 to the fourth power plus 2 to the fourth power plus 2 to the sixth power, right? So this is 2 to the 10th power. 2 to the 10th power, and if we change these to 1, 1, and 2 to 2 to the first power and 2 to the zeroth power, then we can see that, yeah, let's change this one to f2 to the zeroth power, and this is f2 to the first power, and so we could see that each so the power of each result is the sum of the powers on the two, like it's the sum of the powers in the preceding f, right? So 0 plus 0 equals 0, and 1 plus 0 equals 1, 2 plus 1 equals 3, 3 plus 3 equals 6, and so this will be 0 plus 1, this will be 0 plus 1 plus 2, this will be 0 plus 1 plus 2 plus 3, this will be 0 plus 1 plus 2 plus 3 plus 4, and so f to the 2 to the 100th power, this will be 0, this will be 2 to the 0 plus 1 plus 2 plus 3 plus all the way to 99, right? And so this would be 2 to the 9, this would be 2 to the 99 multiplied by 100 over 2. So this is 2 over 99 times 50. This is 2 to the 4,950th power. This is the same as D. The answer is D. Okay, so the last problem number 25. 3 mutually tangent spheres of radius 1 rest on a horizontal plane. A sphere of radius 2 rests on them. What is the distance from the plane to the top of the larger sphere? Okay, so let's say that there are the 3 spheres like this, and then they are mutually tangent, so there will be like this tied together. And if we connect the midpoints, then we could see that this is like that, and like that. This is a straight line. Okay, and so we would be able to say that this is 2 because there's 2 radii of 1, and this is 1 because the radius is 1, and so this would be root 3, right? But then the distance from the center of the 3 circles, so that will be right here, center to the center of one of the circles would be, so the distance would be root 3 times 2 over 3, and it's 2 over 3 because in this triangle, let's put an equilateral triangle right here, so it's an equilateral right triangle, no, so it's an equilateral triangle, right? And so if we can just put an equilateral triangle here, oh man, like this, yeah, let's just say that this is an equilateral triangle, then we would be able to say that since this spot is the center of the triangle, and it's also the center of gravity of the center of gravity of the triangle, right? But then yeah, and so this would be the same, this length would be the same, and this length would be the same, right? And so since the whole thing is 60, and this would be like equal, like the equal angles, this would be 30 and 30, and this would be 60, right? And this would be right angle, and right angle. And so if we call this 1, then this will be 2, right? Since it's a 3069 triangle, and since this is 2 and it's all the same, this would be 2 and 2. And since this is 1 and it's all the same for here too, this would be 1 and this would be 1. And so since this is one straight line, we can say that the ratio of this length to this length is always 2 to 1. And so by that, we can say that this length is 2/3 of this whole line. So that's why we get root 3 times 2 over 3. So this is 2 root 3 over 3. And so and it says a sphere of radius 2 rests on them, right? So there's a sphere of radius 2, and then we have these two circles, and they are ever so slightly apart. That's because of right here, if you see, there's this small length that is between the center of the whole thing and one side of the sphere, right? So this little part is what matters to us, and so that would essentially be the distance between, if there's a line here, yeah, then that will be this distance, right? And so we found this whole distance, right? And so that's the same distance as the distance from here to here. And so this would be, let's move this up a bit. This will be over here, yeah, and then this will be over here. Let's say, yeah, let's put this over here. And so this will be this length, right? So it's 2 root 3 over 3, and this length would be, this is 2 and this is 1, so the sum is 3, right? So this is 3. And so so what we want to find is the distance from the plane to the top of the larger sphere, right? So we have this length and this length, and so we only need this height, right? So the height of this triangle, height would be root and then 3 squared minus 2 root 3 over 3 squared. This is root 9 minus 4 over 3. This is root 27 minus 4, so it's 23 over 3. So this is root 23 over 3. And so since this much is 2 and this much is 1, let's so this much is 2, this much is 1, and what we want is the sum of these 3 blue lengths. And so it will be 2 right here plus 1 right here plus this length, which is this. So root 23 times 3 is 69, so root 69 over 3. This is 3 plus root 69 over 3, and so the answer is B. That was problem 25, and thank you for watching.